Hello everyone, welcome to my video on finding the angles in a right angle triangle. My name's Darren from Maths Guru, but you already knew that. You've been watching hundreds of my videos before and have already subscribed, haven't you? Crickets, okay. Well, that's got awkward. If you could subscribe, that'd be massive. Why? Because who watches maths videos? You're only watching this because you've got to. It's not like you were sitting tonight like night now going, oh, I'm a bit bored. Let me think, what do I watch? Oh yeah, I'll fire up a maths video. No one does that. If you can subscribe, it just lets me know that someone is watching, believe it or not. And makes it seem that sitting in this room on my own isn't completely in vain. Now, behind me are my learning objectives. Know how to find the missing angle in a right angle triangle and be able to use the CAS. You're going to go, what's a CAS? It's a calculator over here in Australia that basically will allow us to find angles, but all calculators let us find angles. And in fact, this course, although I'm in Australia, is universal around the whole wide world. Now, this is sort of a recap slash reteach slash sort of, you've done this before, let's just put it back into your head a few years later. And in my previous videos, I've looked at things like SOHCAHTOA. I can't help myself. Every time I do it in Japanese, SOHCAHTOA. Anyway, moving on. And we used it to help us find the missing side lengths. Now, that was lovely, right? We worked out that, you know, once we've labeled our right angle triangle with hypotenuse, and the opposite and the adjacent, the rest of it really came down to banging it into my calculator or using my solve function. Now, for right angle triangles and finding side lengths, the solve function is really, really easy. For angles, we can still use it, but we've just got to be a little bit more careful. All right, so SOHCAHTOA is still going to be useful. Now, when I was in the United Kingdom, this worked absolutely brilliantly. And I'll tell you why, because our calculators over there didn't have controls and shifts. They only had a shift, and it was much more basic than this. And I used to say to students, right, well, if we know that sine theta is equal to 0.5, what are we trying to do? And they look at me and they go, find the angle. And I go, yeah, no, what do we need to do? And in the end, what I was trying to say to them was say, we want to shift the sine out of the way, all right? I walk down the corridors at the moment. If I want people to move, I've got a choice. I can say, excuse me, please, young sir, would you mind moving? Or I can just go, shift. It's not very polite that out of the way, but shifting the sine out of the way would leave the theta or the angle on its own. And the only place it could shift to was the other side. And then we had to remember that we needed to put that little -1 there because we had to realize we'd shifted the thing to the other side, and ultimately could just put that in my calculator. Obviously, the calculators over here have these control buttons, and that makes life a little bit more complicated. But more importantly, we have a trig button. Now, sadly, I can't use my class pad anymore because the license has expired. That's really awkward. But anyway, fingers crossed, my class pad I can use at some point. But let's stick with the TI Inspire for the moment. Right. Now, when we hit that little trig button, we get this. Now, obviously, that was stuff you played with one day when you got a bit bored in, I don't know, geography or history or chemistry or whatever else. But now, the ones that we're going to use all of the time when we are trying to find angles are the sine, the cosine, and the tan one. Now, again, it's fine because as I down the bottom there, if I had sine theta equals 0.4, I can go solve, he says, type in sine. I can do, I can do solve, comma, theta. Oh, no, hold on, we can't do theta. So what did we say before? We'd probably make that x. But the problem with doing that is your calculator is going to give you a really funky answer. Now, we can solve that in lots of different ways, but sometimes it might just be easy to realize that when we have sine of x equals 0.4, I want to shift the sine out of the way. It moves to the other side and becomes sine to the -1 of 0.4. Okay, your calculator is going to cope with that a lot better. Now, obviously, as I say here, I've got a screenshot at the moment. When I put that into my calculator, sine to the -1 of 0.4, out comes a value. Now, basically, that's a side length. That's what we're trying to find. Yes, you probably don't know what I'm saying, but where did that come from? That's coming up. But the point of it is that now is a side length, and we're going to have to round that to some sort of accuracy. Now, the questions might say to you, round it to 2 decimal places. And if that's the case, throw your head up and go, thanks. I don't know who you're throwing it up to, the people living in the apartment above at the moment. But anyway, yeah, but the point of it is, that's lovely. If it says significant figures, learn them. Because over here in Australia, particularly at year 12, the examining boards love asking you to round to significant figures because they know lots of you can't. Seems a little unfair, but it also seems random that it's something you can learn, and probably relatively quickly. Okay, now the other thing to notice here is to make sure that your calculator is in degrees mode. Now, if you're not sure how to get it into degrees mode, you'll probably see on my screen at this moment in time. If I move my mouse and click on degrees, or he says doing the screen, click on degrees, it changes to rad. Click on it again, degrees. Click on it again, rad. Now, if your calculator can't do that because you've got an old software, well, get it updated. Your teacher can do that for you. Alternatively, just click on dock, settings and status, document settings, and basically it's this angle one here. Don't worry about gradient. We are only ever going to be interested for general maths in degrees. Okay, now let's go back to showing you what could have happened if I did solve. So let's do menu 3.1, I think it is. 3.1. Oh no, that's not right. Awkward. Thought I remembered that there and then. Yeah, no, menu 3.1. It was. What happened there? All right, solve sine. Oh, let's use the actual shortcut key, Darren. Solve sine of x equals 0.4, and I'm going to do comma x. And your calculator is going to go, and it's going to give you something really, really strange. You're going to notice we've got an N1. Now, if you did it on your calculator, that might be P1 or R1 or N7. Who knows? We've got an OR, and we got, what on earth is this N1? Well, to explain very, very quickly, when we draw our graph of sine, we have lots and lots and lots of solutions for where the graph of, or the line of y equals 0.4 will cross through. So at the moment, there's 1, 2, 3, 4, 5 solutions showing. That's just the 5 showing. It actually goes to infinity and beyond. So in fact, there are an infinite number of solutions. And your calculator is trying to say to you, hey, I've got an infinite number of solutions. And it gave you a way of finding all those solutions. Now, you don't need to know how to find all those solutions. What you do need to do is, if you are going to do it this way, limit the number of solutions as possible. Now, the way you do that is you go control and equals, and you'll see a little line. That's called a pipe symbol, okay? So we're going to pipe. That's weird, isn't it? It's like baking. And what I'm trying to say now is I want my values to fall between 0, less than or equal to x. Now, you're going to turn around and say, what did you do there? Fire up your control equals button. Hit less than or equals to, all right? On a keypad, you can actually do less than equal, but anyway. And I don't want my values to be any bigger than what? Well, bearing in mind we're using triangles, the biggest any angle could be, theoretically, is 178 degrees. And you're going to go, huh? How's it 178 degrees? Well, angles are always, we've always got 3 angles. That could be 1 degree, that could be 1 degree, and then in which case the biggest that's going to do. But we don't do that. We say we want all of my solutions between 0 and 180. And lo and behold, out comes 2 solutions. Now, we'll come back a little bit later on to why there are 2 solutions, but to be fair, it seems a lot of faffing around when, if we go back to what we did on our calculator here, just by doing sine to the minus 1 of 0.4, it gave me that 1 solution. Okay, so that was a lot of talking. Let's have some examples. Right, well, the first example says there that the sine of theta is 0.8480. So on theta on its own, I've got to shift sine out of the way. All right, so shift it to the other side, 0.8480. And what you'll notice is when I put that into my calculator, what comes out? Oh, 57.9948013. And again, depending on what it says, so it says correct to 1 decimal place. Well, if I correct it to 1 decimal place, this is the way I do it. I put a line after the 9, not in highlighter, I don't, because that would be silly. I put a line after my first decimal place, and I look at the value after it, and I say, well, that 9 would make that 9 bigger, but that 9 would make that 7 bigger. So, in fact, in that situation, it would come out to be 58 degrees, or 58.0 degrees. What about cosine theta equals 0.5? Absolutely the same. So, we've got cosine of theta is 0.5. Theta is shift out of the way, cos to the minus 1 and 0.5. Put it in my calculator. And out comes beautifully 60 degrees. No rounding there. And then again, nothing different from the last one, where we've got tan of theta is 1.67. So theta is tan to the minus 1 of 1.67. And guess what? We put it in our calculator and outcome 0.4, or well, to one decimal place, 59.1 degree. All right, so let's look at some examples. Example 1, finding an angle from two sides. Right, there again, rules to all of this. There are things you do. Number 1, label my sides. All right, let's label my sides. We can do that. There is my angle. There is my eyeball. It's looking at the opposite side. There is O. There is my right angle. It is basically got an arrowhead pointing to my hypotenuse, and that must be my adjacent. Now, I'm going to colour in the two sides of which they have given me, and it's that one there and that one there. And so I've now got to label, so 1 was label my sides, 2 was what? Highlight my, we can highlight the pieces of information I'm going to use. And number 3 is write SOHCAHTOA. I can't help myself every single time. SOHCAHTOA. Anyway, right, SOHCAHTOA, and then try and work out which one we want to use. Well, which one do we want to use? We have and O, O and H, it's SO. So therefore, I'm going to write that the sine of theta is equal to the opposite over the hypotenuse. I don't like theta. It's too hard to draw, so I'm going to use x from now on. So there's my, I'm not being a snake, it's formula. Sine of my angle, I don't know, and I'm not writing theta, where x is equal to the opposite side length, which is 19, divided by 42, and that's where everyone goes, I don't know what to do now, it's not in a decimal. Doesn't matter. Actually, life is easier if it's in a fraction. The point of it is, he says, making that an equal sign, is we now know that x is, because we've got to shift the sign, sine to the -1 of 19 on 42 equals, I'm going to fire up my calculator, and there we go. There is a sine to the -1 of 19 on 42, which gives me, what do I have to do? One decimal place, 26.9 watt. Well, it didn't give me any units, so it's a side length. We're good. We'll just leave it as 26.9. Next example, we are guns at this now. Number 1, label my sides. There is my eyeball looking over there. So there is my opposite. There is my arrow pointing to my hypotenuse. That must be my adjacent. All right, I'm going to draw some pretty circles around there because I can. Not that it actually helps. I'm going to highlight the side lengths that I'm going to use, which is that one and that one. And so therefore, what do you got to do? Write down saw. Oh, not in green. Let's not do green. Green's horrible. Saw. I defy you to do SOHCAHTOA. SOHCAHTOA. Oh, I've done it. All right, chillax. Right, SOHCAHTOA. I did it twice. What do we got now? We've got the adjacent and the hypotenuse. The adjacent and the hypotenuse, which is cos. So the cosine of the angle is equal to my adjacent divided by my hypotenuse. We want the cos out of the way. So cos to the -1 of my adjacent over my hypotenuse, which is going to be my adjacent side length is 8, he says, writing in rubber again, and my hypotenuse is 14. And again, putting that into my T-Inspire calculator gives me a side length of 50, 2 decimal places in this one. They almost tricked me. Did they trick you? No, of course not. 2 decimal places is 55.15. Did they give me units? 55.15. No, so I won't leave any of my units in there as well. See? Basically, these are so repetitive. There is no difference in any of these. Later on, we'll start using the solve function. But for now, just use the get out of the way, the shift. All right, thanks very much for watching. Did we actually do what we said we're going to do? Know how to find the missing angle? Yep. Use the CAS to, yep, we're done. Thanks very much for watching. If you can subscribe to my YouTube channel, that would be amazing. If you want to head over to mathsguru.com, all of these videos are there. Free to sign up. Summary notes and summary books and all sorts are there or coming. Hopefully I'll see you in the next video. If not, please take care and stay safe. Bye-bye.